Hello everyone, welcome to ExamPreptool DSA challenge number 28, which we given in the previous class, right? We given this challenge. I hope you people maybe tried, right? So I will try to solve this problem. Now let's see this. See everyone? So two BSTs are given. What the problem is saying is, two BSTs are given. We have to find common nodes. That is a problem. That's what this problem is. Common nodes we have to find. Let me read the problem. Given two BSTs, remember it's a BST. Find common nodes. In both the BSTs, whatever common nodes are there, you have to find. It's almost like intersection, I think so. Right? So I will try to give some examples. Then afterwards we will go to the actual story. Tree can be anything, but it should be a BST. Whatever format it can be. There is no relation between how many elements are there in both. Supposing that m elements here, n elements here. But it is a BST, right? So let me write it. It is a 50, it is a 60, it is a 20, it's a 40, it is a 10. Now let me go further. It's 100, right? It's a 100. Maybe it's, I can say it's a 160. So 160. It may be 150. It is assume that it's a 150. It's a 180. So 160. It's a 200. It is maybe, I think, let me try here, 40. It may be something like 20. So in these two BSTs, I want to find out common people. I think one way to solve this problem is, in these two BSTs, common people you want to find out, one way to solve. So take the first element of first BST, 150. Check everywhere, right? In the second one, is 150 available? In the BST, searching for one element, n time worst case. 150 available in this tree are not verified. In the BST, searching for one person, I think it's good for searching, but average case better. But worst case, if you observe, it will goes to n time. Right? N people are there, n time. So for the first person, 150, you have to check everyone n time. For the right 20 also, right, n time. Every person. Worst case I'm talking. 10 also, n time. And so on. Last person, let us enter 160. That is also n time. So every time n, like that n time. So time complexity of this problem, brute force method. Order of m and time. Order of m and time complexity. If anyone having any doubt, please let me know. So that is the first approach. So you may say that, sir, what is the answer for this? Is 150 available in both? Is 150 available in both? Yeah, 150 will be printed. Is 20 available in both? Yes, 20 also printed. Is 10 available? No. Is 160 available in both? Yes. Is 40 available in both? Yes. So this is the output. Common people you have to find out. This is the answer for this. Everyone know brute force method will take order of m and time. Every person you have to check. Right? Every person you have to check. Let me adjust here. Every person you have to check. I'm using another color. So for the first person, n time, second person, n time, like that, m times n, m. You may say that's a binary search tree searching for one element. Best case one, yes, true. Worst case is n, because this BST may balance, may not balance. May balance, may not balance. Worst case is n, best case is 1, average is log n. It is better for average, right? But AVL tree better for all. AVL tree better for all. Height balanced BST is AVL. That is better for all. But BST better for average. Anyhow, time complexity of this algorithm is order of EMN. Right? So I think I written also. One algorithm is compare one by one. Yeah, this algorithm we are already done. Order of EMN. There is no extra space also. Taking first person, comparing with all. Constant space extra. Order of 1 space extra. We have nothing to do. It's a brute force method, right? Now see the algorithm 2. See the algorithm 2. Algorithm 2 is, right, because of tree is mentioned as a BST. Because of tree is mentioned as a BST, because of BST. Careful. If it's a binary tree, I may not able to give this algorithm. Because of it is a BST, in order traversal of BST is going to be sorted order. Is going to be sorted order. Right? So what you do is, for the first BST, find out the right in order. Second BST also find out in order. Both the in orders, compare both are equal or not. Right? Let's check. Let's check here. First step. Algorithm to first step is, because of BST, I'm writing. Because of BST, I'm writing the second algorithm. See, because of BST, first BST in order find out. Because of BST, I'm saying very clearly, because of BST, first BST in order find out. First BST in order find out. How much time? One scan, order of n. And after finding first BST in order find out, store in array. Let us that it is this array name is in order 1. I1 is it. Second one, second BST in order find out. This will take one scan order of n time. Store in another array that is in the I2. Right? M time for first in order, n time for second in order. So for the first one, answer is available in the I1. Array name is I1. Because of in order, I given I1. Second one in order is available in another array I2. Right? First one in order is available, right, in the I1. Second one in order is available in I2. But remember, both are sorted. Both are sorted. Then what you do is, both are sorted, then what you do? So to find out the common elements, you can apply merge algorithm. We studied in algorithm subject. You can study, right? You can do merging of two sorted arrays to find out intersection. Sorted array to find out intersection, please apply merge algorithm. So merge algorithm, you know very well, whichever smaller you take. Suppose E is smaller, let's see, here one pointer, there, here one pointer. So if at all E is smaller, take him in the answer. If at all E is smaller, take him in the answer, then go further. If at all E is smaller, take him in the answer. So I think, right, when you do the merge algorithm, third one, third step I'm writing. Here I'm writing third step. Apply merge algorithm to solve. Sorry, apply merge algorithm to do intersection. To do intersection, apply merge algorithm. That is the third step. If you think it is not visible, I will write it. Next row. I will write in the next row. Second step is over. See the third step. See the third step once. Apply match to do intersection. So remember, match algorithm will take m plus n time. Right? Over. So m here, n here, m plus n here. Total order of m plus n time complexity. Total order of m plus n time complexity. Right? But what about space? I think this space is required. This space also required. Order of mn space, m plus n space extra. Order of m plus n space extra. Time complexity order of m plus n. Space complexity is also order of m plus n. This is the second algorithm. So these two are not that much important, but I want to give some idea I given. But see the major algorithm. Almost similar, but third algorithm having one more nice clarity. What the third algorithm saying is, listen, what the third algorithm saying is, same story. You no need to store the in order, right? So first tree in order in the I1, second tree in order in the I2. There is no need to store. Directly on both the trees, you can apply start comparing. Means in order you can do directly. Whenever you are equal, it's print. But how to do? You may say that take stack, iterative approach. This is called iterative approach. Using for loop, while loop, you can solve it. The purpose of this one is no need of two extra arrays, I1 and 2. So let me write now. The same thing like previous, no need of two extra arrays to store in orders. This is the idea. No need of two extra arrays to store in orders. Then how will you do? Directly. How it is possible? How it is possible? So I will take one while loop. I will take internally some stack. With the help of stack, we can do it. Right? So how code also I written, I will explain also. Code also I written, I will explain also. Let us assume, let me say this. Let us assume this is one BST. I'm giving just idea. Careful. Program also there. I'm just giving idea. This is one tree. This is the one more. Rough estimation. BST. Let me give some numbers. It's 100. It's a 120. It's a 130. It's a 140. 100, 120, 130, 140. It's going to be 110. Okay, so here if you observe clearly, it's here if you observe clearly 50, it's a 60. If you observe clearly here, it is a 40, it's a 43, it's a 48, some numbers. It is 20, it is a 30, it's a 10. But if you see the numbers here, let me try. It's 80, it's a 150, it is 20, it is a 10, right? Next one, it is a 30, it is a 40, it is a 25, some numbers. But remember, both are BSTs. Right? First one also BST, second one also BST. So here I am not using any, right? Here I am not using any extra array. So I will take stack. See, I will take stack here. Both the places I will take stack. Both the places take stack. Right? So what you do is in order you have to, it's a very simple here, iterative approach to find out in order. In order purpose, iterative approach means for loop, while loop you have to use. Normally on the trees, to do in order, post order, pre order, we used to do recursion. Normally on the trees, to do in order, pre order, post order, we used to do recursion. Now we are doing the same thing without recursion. Means we will take stack and we will do. So we are taking stack and we are doing. Let's start now. In order means what? Root. In order means left to root right. In order means left to root right. Right? Now see what will happen. See this algorithm. See this algorithm. Last step. See. Print common people. This is the function. Let us assume that I have two trees. Root 1, root 2. I have to print the common people. Let us assume I have two trees, root 1, root 2. I want to print common people. So I call this function, root 1, root 2, I call it common people. So let's see this one, S1 and S2, two stacks. S1 stack, S2 stack. Let me write. It is a S1 stack, it is a S2 stack. It is a Python program, two stacks I took, S1, S2. Now root 1, root 2 both went. Right? Now see the first step. While one condition is always true. Now see the answer. If root 1, everyone know, right? Whenever trees are linked list, this is the first line. If root 1, that means if the first tree is not empty, right? I think everyone know, in both the trees, I am at the first node. This is the root 1, this is the root 2. But in order means everyone know. In order means everyone know. Left first, root next, then right. This is the in order. Both the places, here R1 here R2 here. Right? First I am asking, if root 1 means root 1 is not empty. Means if node is there. Yes, node there. Right? So see this one. I think it is true. If root 1 true, yes, node is there. Root 1 means first node address. Root data means data. Root left means left person. Root right means right person. Root data means this one. Root means this address. Root means this address. Yeah. While root 1 not empty, of course, then what you do is add root 1 to the stack. So 100 will be added. Append means push. 100 will be added at the end. Then some people are asking, sir, why are you pushing 100 inside stack, sir? You may ask that. Remember, in order means first to not root, first left, then root, then right. So I am at the root, which is not empty, right? Wherever I am, some people are there. My goal is not printing the root. My goal is printing the left people. So what you do is this 100 will be pushed inside stack, right? Then I will go left side. See, if root 1 is not empty, print root 1 in the stack. Root 1 is equal to root 1 left. So you will go to here. And one more thing is, if condition true, else condition, right? First one is true, second fail, third also fail. So else if means what? If the first two true, second you don't check. If the first two fail, then only I will check second. First two true, second, third one no need to execute also. Can you go to last one? Fourth also else, it will also not execute. Then what happened? Then you will go to for loop again starting. Then again for loop starting you will go. Sorry, while loop again starting you will go. Because everything is going on within the loop. Remember, whenever this while loop is going on, every time one will execute. Either 1, 2, 3, 4. Out of these 4 people, one person will execute. First person is 2. Then append the root to the stack. Root is equal to root left because I cannot do the root first. I have to do left then root. Until that time, root will be waiting in the stack. Okay, that's perfect. Now this while loop once again you came back again ask, is root 1 is null? Root 1 is empty? No, same story. Then but I want left because without left I cannot print root. So I will say to this person, you also can stay in the stack. You waited, then root is equal to root left. They are waiting in the stack because after left over I will print root. So similar way, same story. 20 will be pushed inside stack. Root 1 is here. Next one, what will be pushed? 10 also pushed in the stack. Then you go to left. Right? After 10, you will go to left. See, append the root 1 to the stack S1. Then root 1 is equal to root 1 left. So you will go left of this. Then also there in the stack, you go left of this. Remember, no one there means left is null there. Right? Null or none, whatever it is. Null and none both are same. Left is none there. None means fail. Null also fail. These are all same. Null also fail. None also fail. 0 also same. These all are same. Now I want to go 10 left to. As usual, I kept the root inside the stack. I want to go left of this. Left of this is null. Right? See this one. After completion of right, this is 2. Right? Append also 10. Root is equal to root left. Root left is null because of if executed 1, 2, 3, 4. No, right? 2, 3, 4 not executed. Then you will go back to the while loop once again. Now what is the root 1? Now root 1 is null. If root 1 fail, because of 1 fail, I will go to second. Do the same story. Remember everyone. Everyone remember. Now root 1 is null. Now root 1 is null. That is the reason first condition is fail. I will go to second one. Now root 2 is null. No. Then what is the answer? Same story. 80 push in the stack, go to next. Right? 20 push in the stack, go to next. 10 push in the stack, go to next. Not there? Not there, so null. So both are null. Remember, this 10 left also null, right? Which is R1. R2 is here. R2 is outside null. Right? Next one. So 10 left also, 10 left also null. That is R1. So now both are null. Both are null. So now see this one. R2 purpose, right? So R1, R2, right? R1, R2. So what happened is, careful, careful. R1, R2 came, R1, R2 came. As of now, R1, R2, both are null. Both are null. See, until R1 becomes null, right? First condition will execute. Until R2 becomes null, second condition will execute. Now, when you come to third time, R1 also null, R2 also null, then check. Both are null, R1 also null, R2 also null, both are null. Then you came to third line. Length of S1. S1 contain many people, which is not equal to 0, of course. S1 not equal to 0 and S2 also not equal to 0. In both of them, some people are there. So condition is true. Then what you do is, because of both of them, some elements are there. You can do some work he is doing. What is doing? So root 1 is equal to now pop this. Root 1 is equal to now stack contains so many people. So root 1 is equal to root 1 not equal to null, not equal to 0. Root 2 also not equal to 0. So both the people are having something. Then root 1 is equal to keep this. This is a root 1. Root 1 is equal to this. Right? Root 2 is equal to root 2 is equal to root 2 is equal to what is the answer? Right? Again, who is the top of the stack? Whoever top of the stack, that person take in both of them. Root 1 is 10, root 2 also 10. Now ask, are they same? Whenever this one, whenever this is, right, this is true, then root 1 is equal to take the topmost one, which is 10. Root 2 also, in the second tree, topmost one you take, which is going to be 10. Oh. Now check. Condition 2. Third condition 2. In the 3 1 is going on. If root key is equal to root 2, both are equal, then if both are equal, print it. Because of both are equal, 10 print it. Afterwards, after printing over, pop this. Pop this also. Right? In both the roots, data is same or not check. Yes, print it. Then pop both the people. Popping is nothing but it will go here, Pop both the people. Afterwards, everyone know root is over. Root right you will go. So R1 is equal to R1 next to R2 is equal to R2 next. So who is the R1? 10. 10 right is no one. 10 right is here also no one. Both are null. Both are null will go. But remember in the three, right? In the 3, if you observe clearly, if first condition true means second cannot be true, third also cannot be true. Now inside the while loop you will go as usual. Remember both are null. So I think first condition failed, second condition also failed. Then you will come to third one. Both are not equal to null. Yes, true. Then again same. E will be popped out. Whoever there top 20 popped out. Whoever there here 20 popped out. Both will be popped out. Now, right? It's not popped out. Both are not equal to null. Right? R1 is equal to right top. R2 also top. Then immediately, right? Then immediately, both the data are same or not verify. If it is true, print him. 2020, I think printed. After printing is over, pop both the people. From the stack, pop both the people. From the stack. After popping on, you know very well, after root is over, you have to go to right. Root is equal to root right 30. Root is equal to root right 30. So like that, it is keep on going. Right? So if it is equal, this is the story. If it is a less than, it is the story. If it is a right side, this is the story. If you do that, you will get the in order. I hope you got the clarity. Simply take one while loop. Instead of doing the in order using recursion, you are doing in order in the form of a stack. But one important thing, out of 1, 2, 3, 4, every time, one will execute. But inside three, again, 3 cases. If it is equal, if it is less than, if it is greater than. Please take care. Right? There is no requirement of taking some extra array. Like this, you can manage. Like this, with the help of stack, you can manage. Some people are asking, sir, if I do that, how much space I will get? Let me write now. Time complexity is simply in order only. Order of n plus n. No problem. But if you see the space, because of no extra array, how much space is you are doing in order? You are going like this. Every one of 3 extra spaces right? Depth of the stack. I think the first tree height is H1, second tree height is H2. So those are enough, right? How much height is there? That much stack size. How much height is there? That much stack size. Stacks purpose it is. So I think space complexity order of H1 plus H2, which are heights of first tree, second tree. But I hope you got it. I'm thinking that mostly you got the wonderful clarity. Program also there, please verify. Right? So I simply done in order of a BST using iterative approach. In order of a BST using iterative approach. I simply done this. I hope you really got it. If anyone is having small doubts, see the program. Still doubt there in the comment section, you can comment. In the comment section, you can comment. I simply done, if anyone having still problem, I am writing here. I am writing here. Right? In order, iterative approach, not recursive approach. Iterative approach. Iterative approach. Right? Time complexity, same thing like previous. Space you can say. Space is order of H1 plus H2. Right? Perfect. Perfect. Yeah. See you in the next class. Any doubt is there in the comment section, you can comment.